I modeled this component in Rhino using a simple loft between upper and lower profile curves. The component has a vertical edge and a chamfered corner to the bottom right. The component has a thickness of 8 mm. I'll hide the poly surface so we can see the profile curves. Export the upper and lower profile curves as separate DXF files using CAM metric settings. Launch TechnoCam. In order to do a 5-axis cut, you need to nest the profile curves and save them into an SLD file. Right-click the SLD pane and select Edit the shape. Define the name of the SLD file. Now load the upper and the lower profile curves. Also, you must define the thickness of your material. I'll leave it at 8 mm. When you're done, click Continue/Close. Both the upper and lower profile consist of two curves, an inner curve and an outer curve. By using combination profiles, we define what curves are linked, inner to inner and outer to outer. In this case, profile 1 to profile 1 and profile 2 to profile 2. Now that the profiles are linked, we need to define how the linked curves are connected. This is similar to lofting in Rhino. To do so, I click the first profile combination and select Define Edges Combination number 1. You will see a number referring to each point on the curve. Basically, you connect similar numbers from one curve to the other. The curve direction must be the same, going either counterclockwise or clockwise. Also, the starting points must be aligned or twisting will occur. In this case, I just need to flip one of the curves to fix the issue. Now click the number field and connect the points. The color of the cursor indicates what curve you need to pick a point from. If your curves has a lot of numbers, you can skip some. Just make sure to define the points that are essential for your curves to loft nicely. When the points are connected, select Make Cutting Profile with 5 axes. If the loft looks correct, just close the window. If not, use Erase all the edges from the Edit menu and start over. Holding the Control key and the left mouse button, you can zoom in the preview window. With the left mouse button, you can drag a line between the two profiles showing the path of the water beam. For the outer profile, the curves direction and starting points match. Also, the curves are directly above each other, so just select Elaborations, Define Edges per Homogeneous Profiles. When all profile combinations are defined and lofted, click Continue/Close. TechnoCam will show a preview of the SLD file. Save the file and close the window. Before cutting, you will need to make a cutting bill. Like the 3-axis tutorial, I'll select Iron Steel, 0.25 mm orifice, medium quality. Since the component is 8 mm thick, make sure to select 8 mm for the cutting bill too. Now double-click the SLD file from your SLD pane and import the shape. I'll add a plate of 600 by 400 mm. Then double-click the plate and place the SLD file on the canvas. This is simply a matter of clicking once on the SLD file and double-clicking on the canvas. Now make the cutting sequence and export the cutting bill as an ISO file.